Oh yeah.
Hello and good day, geometry. We are plugging away. Owen, Nathan, that's why I said your names. Yep, no, that's why I said your names earlier. So this is now the second time. We're literally 3 seconds in. I didn't even get through my intro, and already we have problems. So if you end up out in the hallway later on during class, we can revisit this, and you'll know exactly why. Good day, geometry. We are going over proofs for a second time. 3 more of them to do it. Again, you won't actually have to write a full-blown proof on the test yet. You will for PO24. This is still just to get you comfortable with the format, the theorems, get you working with them, everything like that. So here we go. Given ABD is a right angle, also given CBE is a right angle, and our job is to prove that angle ABC is congruent to DBE. So let's kind of hash this out a bit here. ABD is a right angle. Where's ABD? Well, from A, vertex B, down to D, this is a right angle here. It is 90 degrees. And we're also told that CBE is a right angle, which is from point C up to vertex B, down to E. This is a right angle here as well. And we are supposed to prove that ABC is congruent to DBE. Now, ABC and DBE certainly don't look congruent, which makes me wonder if I made a whoopsie-doo.
Whoopsie-doo.
Okay, next one.
Definitely does not look like a right angle.
No, it does not.
Next one.
No, it is not.
But
It probably is right.
This is one of those times when the diagram speaks for itself. Not drawn to scale. We'll put it like that. Yes, Eli. Oh, there might not be enough information, but there is here.
Are you able to put one of those?
no, there is.
I will not put one of those in the test. Okay. Andrea, where do we start?
Okay, so first you need to make your little table
Ooh, sure.
with
I
the
like that.
statement and reason, and
Yes.
then you have to do the givens.
Statements, reasons, and we start with the given, as always.
Yeah, so
The given statement is ABD is a right angle. And I'm going to abbreviate right angle to be RA, just because. And then CBE, I'll move, is a right angle as well. Okay?
You got for just a minute.
Yes. Continue filling this out.
No, wait, can I give it up?
No.
I'm
I need a response.
Okay, Colin. You have a nice YouTube
Okay. Okay, 3, 2, 1, you are quiet. Here we go. Real. Charlotte. Chase, turn around. Andrea. ABD is a right angle. Andrea. CBE is a right angle as well, and the reason for that is given. Okay? Start with the given. Where do we go from here? Who's got a thought? Colin. Briggs.
Well, I was just wondering, can I say the measure of angle ABD is equal to 90 degrees?
You can. Where are you going to go with that?
I don't know. I just wrote that.
Okay, so saying that that ABD is equal to 90 degrees, that would be the definition of a right angle, right? Being told it's a right angle, that tells us it's 90 degrees. However, since we don't have any other 90 degree or any degrees symbols in the figure, I don't know if I'd go that route. I can, now that I'm processing it, I think I see where you're headed with complementary angles, perhaps, and the whole thing. But we can avoid using the degree measures by just sticking with the definitions. Okay, so you're not wrong, but I think your method might be a couple extra steps. And since I only have that much space, I'm going to stick with the definition. Okay? What can we say next? Cormac. Which triangles did you say?
ABC and CBD.
ABC and CBD. They add to be 90 degrees. They're complementary. Okay. So we kind of have to go a little bit extra step first. We have to go that route. We would have to say that the angle ABC plus angle CBD equals angle ABD.
That's addition.
Okay. ABC plus CBD equals ABD. And we can say that, Sam said it, because of the angle addition postulate.
What about
Okay? The angle addition postulate.
I know what to do next.
So, what to do next? Cole,
Reset. That's it.
say what?
Left hand side.
Thank you, Cole.
Yep.
So the fact that we established that ABC and CBD add to equal ABD, and the fact that we're told that ABD is a right angle, now we can go with what Cormac said and say that ABC and CBD are complementary angles. Because we've established they equal an angle that is a right angle, therefore they are complementary angles.
That's what I was asking.
So angle ABC and angle CBD are complementary.
Oh.
Okay. Yeah.
Can I do the final step?
Well, we're not there yet. We're not. I don't think we're quite ready for the
I know
final
this one.
step yet. But what's the reason here?
Because if you add CBD to both of them, it'll make a right angle.
Well, the reason for saying that angle ABC and CBD are complementary. What's the reason we can say that? The fact that we've established ABD is a right angle, and then ABC plus CBD equals ABD, which is a right angle. Therefore, that allows us to say that ABC and CBD are complementary because. Tristan? Cole?
I forgot.
Andrea?
Would it be would it be the congruent complement?
No, it's the definition
Yeah.
of complementary angles. If angles add to equal a right angle, they have to be complementary. So for Colin mentioned earlier about stating a right angle is 90 degrees, I think he was going this route because the definition of a complementary angle is also they add to be 90 degrees. But because a right angle is the same thing, then you can kind of get around the degree measure by sticking with the definition. So it saves a step. It is kind of hard because I'm trying to keep you all quiet and pay attention, but it's working better for some than others. Okay. But ultimately, what Andrea said, as far as trying to get that congruent complements theorem, that's where we're headed. What else do we have to state here in order to get there? Andrea, what do we also have to state?
We have to state that CBD plus DBE equal CBE, and then you have to put that those two CBD and DBE are complementary as well.
We basically have to repeat steps 2 and 3 for CBD and DBE.
Is it alright if I did two angle
Yes.
next to each
So
other?
you folks, I want to talk to Colin here a little bit because he got something to say. Steps 4 and 5, repeat steps 2 and 3, only instead of angle ABC and CBD, we're using angle EBD and CBD.
Oh, okay.
What?
I'm not
I don't have enough
Okay, Colin, what's your thought? You thought we could get there at the next step to
Yeah,
conclusion?
After you stated that, you can use the congruent complements theorem to say that ABC is congruent to DE.
Yep. So by stating that ABC and CBD are complementary, steps 4 and 5, we're doing the same process for EBD and CBD. saying that EBD and CBD, there should be a plus sign. They add to equal angle CBE because of the angle addition postulate. Step 5, ABC and CBD are complementary. We're doing the same thing, only with EBD and CBD. And we can do that because of the definition of complementary angles.
This is very really easy to understand.
Why'd you do like a common sense?
What does that say?
Like, I mean, honestly,
3, 2, 1, you are quiet. Go ahead, Izzy. What?
What is the end of
Complementary angles. CA is abbreviated for complementary angles. What step? EBD and CBD are complementary. Nick?
So for the I did EBE, do you use DBE or do you have to flip it around?
DBE would be fine.
Okay.
Yep, that's good.
What's the difference between step 4 and step 5?
Step 4 says that EBD and CBD equal CBE. And because CBE has been established as a right angle, we can then conclude that those two angles are complementary. Okay? It's a very specific way to work through this, but I did say that proofs need to be very specific. You need to state why are they complementary. Well, they add and equal a right angle. We were told that CBE is a right angle. Therefore, they can conclude to be complementary angles. Ben?
I just want to say something. You can simplify definition to DEF.
Sure.
That's pretty cool.
I just want to say that.
Okay. And so, if we have two angles that are complementary to the same angle, which is the situation that we find ourselves in here, ABC, I should have put DBE because that's the proving statement here. But ABC and DBD are both complementary to CBD. Therefore, because of the congruent complements theorem, we can say that they are congruent.
Okay.
What's the flip? You said we were done.
Guys,
We're done after this.
guys, I like doing it. I like
CCT stands for congruent complements theorem.
sense.
Okay?
I thought we were done.
Nope. Yes.
Could you think of proofs? What is CCT?
Congruent complements theorem.
So it's
Congruent complements theorem.
When would someone be able to look at just the proof and be able to draw out?
I mean, maybe not exactly, but get the relationships down. Like, they might draw that same thing, but have it facing upwards rather than downwards, you know? But yes, in theory, yes.
Okay, so.
If they knew what the terms meant, everything like that, yes.
So could I think of like that
Why can't you just do like a simple equation like CBD plus CBE equals 90 and ABC plus CBD equals 90?
Because in order to use that congruent complements theorem, you have to identify them as complementary angles. And the way to do that, like you could go that route, but you still need to identify them as complementary angles. Okay? Because we don't know what the angle measures of each individual angle is, we have to kind of group them together as complements and go that route for it. Okay? Last chance. This is it. Next time I gotta look back there because I hear a laugh or a talk or whatever, then you just go out the hallway.
How about over here?
Would you like to go out now, Cole? Okay. You've been warned once, twice, thrice. Yes, Brianna. Sure. Okay. Yeah.
Can I go to the bathroom?
No. Okay, moving on to the next one. Again, the point of this is not so much that you can leave today being able to write a formal proof. The plan today is that you can leave today understanding the format of it and a better understanding of how these theorems, postulates, properties that we've been going over fit into all of it. Okay. We are working with this one. It says given angle 1 is equal to angle 3. The measure of angle 1 is equal to the measure of angle 3. Notice we're using the equal sign here, not congruency. Right? When we use equal, we're talking about their values. That's why it's measure of. Okay. The measure of angle 1 is equal to the measure of angle 3.
So they could have like, if measure 1 is 30, then measure 3 is 30.
Correct. Correct. Our job is to prove that the measure of angle EBA, this angle right here from E down to B and up to A, is congruent to the measure of angle DBC. DBC going from point D down to B and out to C. Knowing that 1 is congruent to 3, we need to prove that EBA, the angle in green, is equal to the measure of angle DBC, the angle in red. So, we start. I want to give myself plenty of space here for the statements, and usually it's the statements that I run out of room on.
I can get the first one.
What's the first one, Sam?
M1.
Measure of.
M1.
Measure of.
No. Measure of 1.
Angle 1. Measure of angle 1.
M.
Equals.
M.
Equals.
M3.
Measure of angle 3. We got there.
I don't want to say that.
The measure of angle 1 is equal to the measure of angle 3, and that is because it is given. And like I said yesterday, okay, we need to ultimately prove that the measure of EBA is equal to the measure of DBC, which means we need to introduce EBA and DBC to the party, right? We have to tell what we know about them. Cole?
Yeah, I think about it.
After Izzy comes back, are you gonna go? Okay. Fultinsky.
Right here, angle 2 is congruent to measure of angle 1.
And how do you know that?
Because I don't know.
You don't know, okay? Riel?
Measure angle EPA is equal to measure angle. Wait. One second. Okay. Is equal to measure angle 2 and 3.
Well done, Brielle. Exactly. Okay? The measure of angle EBA. What do we know about EBA? We know that EBA, which is in green here, that's the sum of angles 2 and 3. Right? We don't know if 2 and 3 are congruent, aren't congruent. We don't know the measure of either of them, but we know what we know about EBA is that it is the sum of angles 2 and 3. And what is the reason for that? Why are you able to say that? Nathan?
Because when you add them,
Well, let's be more geometrically correct here.
Oh, I got it.
2 angles that equal another angle.
Okay, Colin?
Angle addition.
Angle addition postulate.
Oh, you wanted to know the postulate.
Well,
I thought you wanted to know why those 2 added.
yes, the angle addition postulate.
Oh my.
That's exactly what I wanted to know, yes. Okay. Let's introduce DBC. What do we know about angle DBC? The measure of angle DBC is equal to what? Maddie?
It's equal to measure of angle 1 plus measure of angle 2.
All right, and I want to write the measure of angle 2 plus the measure of angle 1, just because I'm noticing here I've got this measure of angle 2 in each of these, which I think is going to be a big step later on. We shall see. So DBC is angle 2 plus angle 1, and what's our reason for that, Maddie?
Because of the angle.
The angle addition postulate. Again,
Can you just put it in the same
you
step?
can if you want to.
I knew it.
Okay?
I knew it.
Let's get people get caught. Let's recap here. What we've done is we've taken our given statement, angle 1 is equal to angle 3, and then because we ultimately had to prove that EBA is equal to DBC, we've got to include them in the proof somehow. So we introduce them by saying what we know about EBA. All we know about EBA is that it's the sum of angles 2 and 3. All we know about DBC is that it's a sum of angles 1 and 2. Nathan, where do we go next?
We can answer it.
Hold your
Yes,
horses.
we can.
All right, go ahead. I'll let you.
Because if 1 and 3 are equal to each other, we can substitute them for each other in the equation.
So we can't make this proving statement in step 4 because we have to do what you said first. We have to substitute, right? So let's take DBC. Actually, let's take EBA. Hold on, Andrea. Let's take the measure of angle EBA. And instead of writing its angle 2 plus angle 3, what can we write?
2 plus angle 1.
Why can we write 2 plus angle 1?
Because 3 and 1 are equivalent. Substitution property. Or postulate.
Okay. If EBA is the sum of angles 2 and 3, and angle 1 equals angle 3, then saying that EBA is 2 plus 3 is the same thing as saying it's 2 plus 1 because 3 and 1 are equal. Now here's an example of where we could not use the transitive property. It has to be substitution because we're substituting angle 1 in for angle 3 in a larger expression. It was a lot larger than what we had up on the top one. So this one, you would need to use the substitution property. Okay? Because you're substituting, replacing a value with something else in a larger equation or expression. Right? Now, we've got angle DBC is equal to angle 2 plus angle 1. Angle EBA is equal to angle 2 plus angle 1. So how can we say that the measure of angle EBA is equal to the measure of angle DBC? Everyone shout it out. 1, 2, 3.
ABC.
Oh.
EFG. HIJ. QRS. TV. I did not
Fine, only on Andrea.
Oh, no, I wasn't going to say that. Okay, I had a...
DBC.
I was going to say with, number 4. Could you use...
Folks,
What was the question?
Could you use the addition property?
for 4?
Yeah.
No. Why do you say we use the addition property?
Well, so if A equals B, let's say like measure of the angle 1 is A, and measure of angle 3 is B, and measure of angle 2 is C. And if A equals B, then A plus C equals A plus C.
Right, we didn't add anything to this equation. We didn't add the same thing to both sides or both parts here. We replaced something. So it would not be the angle or the addition property. All right, Brielle, what's our reason for step 5? If DBC is 2 plus 1 and EBA is also 2 plus 1, then EBA equals DBC because?
I know reflex property.
No! Nick!
So, we're trying to figure out the property. Wouldn't that be the definition of conflict?
No!
Right? Transit.
Transitive property!
I was gonna say Lake was right. There's like a 1 in 15 yes.
A transitive property. The reason why, we've got 3 parts here, right? We've got DBC, folks, we've got DBC, we've got 2 plus 1, which shows up twice, and then we have EBA. So if both EBA and DBC are equal to the same thing, they're both equal to 2 plus 1, therefore they're equal to each other. Whenever you are relating 3 different things with equality, it's going to be transitive. Okay? A is B, A is C, therefore B is C. That is the textbook cut and dry definition of the transitive property.
Did I make it yes?
Yes. Real. We don't know and we don't care.
Yes.
Yes.
It's not part of the proof, so we don't care.
I
Right?
care.
All right, that's it for today. Have a great weekend. That's how you math. No homework.